So in our last video, we explained how to solve a rational equation, and I want to get us a little bit more practice doing that. So we've got a couple examples here where we're just going to go through and see if we can solve these two different rational equations. We're actually going to start with the harder one first. So if we can do this one, then we're doing fine. This is about as bad as they get. So just kind of buckle your seatbelt and hang on, and we'll see if we can get through this one. So we've got an equation here: x squared plus 10x plus 17 over x squared plus 9x plus 8 equals 2 over x squared plus 2x minus 48, all plus 1. So the first thing we do, as we well know, is we got to get rid of these fractions so that we have an equation that is a little bit easier to solve, hopefully. So the way we do that is we have to find the LCD of all these denominators here. So to do that, it would probably be helpful to see these in their factored form rather than looking like quadratics. So let's see, this denominator here, I think we could factor that as x plus 1 times x plus 8. And because there's so much algebra in this exercise, I'm going to skim through some of the smaller algebra. So if you need to rewind or replay the video, feel free to do that. This denominator, I think it would factor as x plus 8 times x minus 6. Okay, and so we see all of our little mini denominators. We have a factor of x plus 1, x plus 8, x plus 8 again, and an x minus 6. So the least common denominator amongst all this different factors would be x plus 1, x plus 8, and x minus 6. You don't have to double count the x plus 8. You only need one because there's one here and there's one here. So this giant product would be your LCD. If you multiply that guy through the left side and the right side of the equation, all the fractions would disappear, and that's exactly what we're going to do. Now I'm a little confined on space, so I'm going to be maybe a little sloppy with my notation here. I'm just going to write LCD on the right and LCD on the left, just because I don't have space to write out that giant thing. On your paper, you should actually write down what the LCD actually is on the left and the right. All right, so if we do that, then on the left-hand side, the x plus 1 and the x plus 8 will cancel. So you'll have x squared plus 10x plus 17 times just the only remaining factor of x minus 6. And on the right-hand side, we distribute these three to the first term and the second term. The first term, you'd have a 2 and an x plus 1, because the x plus 8 and the x minus 6 would cancel. And then all three of those factors times 1, you'd actually have all three factors. You'd have an x plus 1, you'd have an x plus 8, and an x minus 6. You'd have a little bit of everything there. So good news and bad news. This equation doesn't have any fractions anymore. That's a great thing. The bad news is it's still pretty ugly. So let's FOIL everything out so we can see what we have to work with, and then we'll try to simplify it and see what we'll do from there. But at least it doesn't have any fractions anymore. So let's FOIL the left-hand side, and again I'm going to go through the algebra kind of quickly. Let's see, x squared times x will give you x cubed. The x squareds, let's see, you'd have 10 minus 6, I think you'd have 4x squared. The x's, you'd have minus 60 plus 17, so minus 43x, I believe. And then minus, let's see, 60 and 42, minus 102 for the constant, I believe. The right hand side would be 2x plus 2 if you distribute this 2 here. And then we've got three factors here. We're going to need to FOIL all that stuff out. To make it a little easier, why don't I just go ahead and FOIL the first two first. That would be x squared plus 9x plus 8. Okay, and let's actually just FOIL that and x minus 6. Would probably be a little easier doing it that way. So x squared times x would give us x cubed. the x squareds, we would get 9x squared minus 6x squared, so 3x squared, I think. The x's, you'd have minus 54x plus 8x, so minus 54, so that'd be minus 48x. And let's see what else we have. Well, let me just double check that one. What was that? Minus, just want to make sure we're doing everything okay. 9x times 6 would be minus 54x, and plus 8x. So that would be minus, I think I checked, minus 46x. Minus 46x. And then the constant, you'd have minus 48. Okay, again, if you need to replay some of that algebra a couple times, that's totally fine. We're just trying to get through this kind of quickly. All right, so now I've got all my individual terms I can see on both sides. Let's start cleaning everything up, maybe moving everything to one side. Let's say I've got an x cubed and an x cubed. We can subtract that from both sides. I've got a 4x squared and a minus 3x squared that I can move the 3x squared to the left by subtracting it. So I would just get an x squared. The x's, I've got minus 43x, but if I add 46, that'll give me 3x. Minus 2x would just be x. So plus x. So cancel all the x's away. Then we'd have minus 102 on the left, but we would add 48 and subtract 2. So I think that would be minus 56 equals 0. So now we have a nice, bite-sized quadratic equation. So this quadratic, if we solve that quadratic, the solutions that we get should be the solutions to the original equation in white that we see up here. So I think this guy will factor, let's see, x and x, I think probably plus 8 and x minus 7. I think that would do the trick. So we get our answers. One solution is x equals negative 8, and the other solution is x equals positive 7. Okay, so that looks pretty good. So now we're tempted just to call that the answer and go to the next problem. Those are the x's, so that if you plug those in back in the white equation, if you can see everything originally written in white, that should make the left side equal the right side if you plug in those values for x. One small problem though, when you look back at the original equation, look at these denominators that you had. You had x plus 1, x plus 8, and x minus 6. You're not allowed to plug in negative 8 for x because they give you division by 0 on the left side and the right side. So this guy is an extraneous solution. You just toss it out like it was never there. But the x equals 7, that one actually works out perfectly fine. There's no issues. There's no reason you couldn't plug in 7 into the left side and the right side. So this would be your only actual solution to this equation. All right, so that exercise there took a little bit longer than I was anticipating. So let's just close out this video right here, and then we'll just make up a next video for our next example. I'll go ahead and show it to you if you want to go ahead and try it. This is obviously a little bit simpler. I wanted to do the harder one first. So you can try this one here, and then we'll actually work it out in our next video.